would. I would. All right, Jordy, let's see if we have any more science questions.
All right. I have a science question here about tsunamis. And the question is, tsunamis are caused by what event? Explosions on land, volcanic activity, sudden changes in temperature, or underwater earthquakes?
Yeah. Excuse me. So there's actually two answers on there that are potentially correct. The answer that people most often give is earthquakes. That's probably what the tester was going for. When earthquakes happen in plates that are under a sea or some body of water, you tend to get large wave action, and I'll talk about why that is. But volcanic activity can also create the sort of energy, the force that can create a tsunami, and so can underwater landslides. So you can actually have, there are gigantic underwater mountains. In fact, the largest mountains on the earth are underwater, and you can have landslides on these underwater mountains or on underwater slopes. And those landslides, the force of them can actually create the force that creates tsunamis. So tsunami is a gigantic wave. It's a Japanese word. I think it means coastal wave or a wave that comes to the coast or something along those lines. But essentially what you have happening is, and I've got a picture that we can kind of look at here. If you want to jump to my screen. Where did I put it? There it is. So in this image, we have an image. Here's the sea surface. Here's the sea and the sea floor. This is a fault line right here. And so we're imagining that there's an earthquake that occurs at the fault line. What you get is an upward force. You can see in the second image, force moves upward. And what that does is it literally raises water into the air and displaces some of the water. And then, of course, gravity, doing what it always does, pulls that back toward the earth. And the force of that coming back down to the earth now, that water is going to move outward very, very quickly at like, I don't know, something like 500 miles an hour. And what you get then is this really intense wave of energy moving through the water. And I'll just point out here that I think a lot of the time when we think about wave motion in water, we think of moving water, like, oh, that wave is getting closer to me. And it's true that the wave is coming closer to you, but the water itself is typically not. The water molecules themselves in a sea, as a wave moves through them, are pretty much staying in place. And really, it's just the energy that's moving through them. But in any case, what you would get then is sort of, oops, sorry guys, yikes, yikes. I just wanted to show you this. This is sort of a standard graphic for wave motion. So you get wave-like energy moving through the water, and you get crests and troughs of waves. And there's kind of an interesting thing that goes on with tsunamis. If a tsunami hits and the first that hits land is a trough, what can happen is there can be actually, it can appear as though the water is receding and that there's really nothing there. There's an interesting story about Persians invading this little Greek town in like 500 BC, and there was a tsunami coming in, although nobody knew it at the time, and a huge portion of the land that was normally covered by sea was suddenly opened up as a trough of a tsunami sort of comes close. There's a gigantic tsunami wave coming behind, but these Persians made their attack across the land that was exposed when the wave pulled back, and then very quickly after, the crest of the wave, right up here, came in and drowned almost everyone who was trying to invade. And so the Greeks on the other side were like, woohoo, and they thought that Poseidon had saved them, but actually it was just a tsunami and just random chance. So kind of interesting.